All right, percent composition. When you think of percent, what do you think of? Well, I think of like 5 out of 10 is 50%, okay? Or, 2 out of 20 would be 10%. Well, what am I doing when I do that? I'm taking the part, okay, dividing it by the whole thing, and multiplying by 100, and that gives me the percent. So for example, 5 divided by 10 would be 0.5. Times 100 would give me 50%, okay? So percents are found when you take the part divided by the whole, multiply by 100, and that'll give you the percent for that part. So we're going to do a similar thing with compounds. It says, our goal here is to find what percentage of the weight comes from each element in that compound. So for example, if you had a whole compound, what percent maybe comes from carbon, what percent maybe comes from percentage of the weight, the total weight came from the hydrogen, what percentage of the total weight maybe came from oxygen. So how do we do that? Well, if you look here, it says to find the percent of each element in a compound, use the following formula, okay? So here's what we're going to do. We're going to take the number of atoms of that element times the atomic weight. We've been doing that already. But this time we're going to divide it by the total molar mass, so the total weight of the compound, and multiply it by 100. Underneath there's kind of a different way to say that, okay? You take the total weight that comes from that element, divide it by the weight of the whole compound, multiply by 100, and that will give you the percent of the weight that comes from each element. So let's do some examples here. If I said, what is the percent for each element in iron 3 oxide? Okay, so first thing you're going to do on this is just write down what your formula is. So we have iron, which we know is an Fe, and this Roman numeral 3 means it's a positive 3 for the charge there. And then we have oxygen, which is an O negative 2. Hey, don't forget what we got to do here. We got to crisscross. And so the final formula then is Fe2O3. So first off, make sure you have a formula. Second thing, let's go ahead and go through and write down what elements we have here in general. So I have Fe and I have O. And how many of the Fe's did I have? I said I had 2. And what about our oxygens? I have 3. So the first thing we need to do is write down the number of atoms of the element, okay? Next thing we need to do is we need to figure out, just like we did earlier, that total molar mass. So how much does each of our Fe's weigh? Well, each of our Fe's weigh 55.85, and each of our oxygens weigh 16. Okay, so what we're going to do now is we're going to take the 2 times 55.85, and we get 111.7. And then we're going to take our 3 times our 16, which gives us 48.0. Alright, so that's the weight from our iron, and that's the weight from our oxygen. Then what we need to do is we need to get the molar mass. So, just what we've been doing before. And when we do that, we find out that the molar mass for Fe2O3 is 159.7 grams per mole for, again, Fe2O3. Now that should look very similar to what we've done already, okay? Now what we need to do is we need to focus on this. How do we get the percent? Well, to get the percent, I take the amount of weight that came from the part, divide that by the weight of the whole thing, and then multiply by 100. So what does that mean? Well, if I want to get the weight from Fe, I take, or the percent, excuse me, for the Fe, I take the weight that came from the Fe, divide it by the total mass of the compound, which we said was 159.7, And then make sure after you get that answer you multiply it by 100. And that will give you your percent for Fe. For oxygen, we're going to do the same thing. Weight of the oxygen divided by weight of the whole thing. Multiply by 100 after that. And that'll give us the percent of the oxygen. So let's do that. If I take 111.7 divided by 159.7 and I multiply by 100, what you'll get there is a 69.94%. And that is the percent of the weight that came from Fe. Then go through and calculate the percent that came from the oxygen. So take the 48.0 divided by 159.7, multiply by 100, and you should get 30.06%, again, of the weight came from oxygen. Now, this is your final answer. How can you check it? Well, your percentages should always add up to be 100. So that's a good way to check it out. Let's do two more problems here. Okay, the next one, what is the percent for each element in CaOH2? So here we've got a polyatomic ion, and we have to remember what to do with that. So again, we start off the same way. We write down what we have. I have Ca, I have O, and I have H. How many CAs do I have? I have one of them. How about oxygens? Hey, don't forget the 2 outside. That means we have 2 oxygens. And then lastly, how many hydrogens? I also have 2 there. So that's how much I have of each element. Now let's find out how much they each weigh, so we can use that to get the total molar mass. So for calcium, I have 40.078. Oxygen is 16. And then your hydrogen is 1.01. So we go ahead and we multiply that through. 40.08 is what I should have there. Should shorten that up. And then I have 32.0. And then I have 2.02. Now, once we go ahead and we add those up, we find that calcium hydroxide, the whole thing, weighs 74.1 grams per mole for CaOH2. But that just gives us the molar mass. Now we need to find out, of that 74.1, what percent of the weight came from the calciums, what percent came from the oxygens, what percent came from the hydrogens. So again, how do we do that? Well, we take the weight that came from that element, calcium, divided by the weight of the whole thing, 74.1, and then multiply by 100, and that will give us the percent calcium. Do the same thing on our oxygen. Take the weight divided by the weight of the whole thing, multiply by 100, and that'll give us the percent oxygen. And then hydrogen, do the same thing for, and that'll give us our percent of the weight that came from our hydrogen. So let's go ahead and plug these numbers in here. Okay, for our calcium, should have 54.09. And for our oxygen, we should have 43.18% of the weight came from oxygen. And lastly, from our hydrogen, we have 2.73%. Now you'll notice that all of those together add up to 100%, which is what we want to see. Okay, very last problem there is we're going to do something a little bit different. And we're going to say, what is the percent of the weight that comes from water in this formula right here? Na2CO3 bound it up with 10H2O. Okay, start off the same. I've got Na, and I have CO, and then remember, keep your waters together, okay? So, there's what we have there. Now, let's go ahead. How many Nas do we have? 2. How many carbons, we have 1. Oxygens, 3. Waters, look for the number that's in front of our waters, and that's 10. Now what we need to do is we need to go ahead and again multiply by how much each of them weighs. So for our sodium, we should have 22.99. Carbon, 12.01. Oxygen, 16. And lastly, our waters, which we said is 18.02. So go ahead and multiply those out. 45.98 for our sodiums, 12.01 for our carbons, 48.00, and 180.20 for our waters. Then we want to go ahead and add those numbers all up. So 45.98 plus 12.01 plus 48 plus 180.2, which should give us a total of 286.19 grams per mole. Now, in this question, I don't need to find the percent for all of those. I just need to find the percent that came from the water. So we take the weight of the water divided by the weight of the total, which is the 286.19, and then multiply by 100. And when we do that, we get that the percent of the weight that came from the water was 62.96 is the percent that came from the water. Now, what percent then came from these right here? This is what's referred to as the anhydrate. Okay, so we have an anhydrate plus the water is equal to what's called the hydrate. So how would we do that? Well, we would just take 100 minus the 62.96, and that would give you what percent came from the other stuff in the compound, which the other stuff is your anhydrate. And so the other stuff, which is your Na2CO3, is your anhydrate, and that is 37.04% of the weight came from your anhydrate. We didn't need that on this one, but on your homework there's some questions where you have to calculate not only the percent of the water, but the percent also of the anhydrate.